All right, so with lesson 2, this takes us back to ratios and proportions, and it's like we always say, make a table. A cyclist rode 3.75 miles in 0.3 hours. Let's make a table. Answer all these questions. All right, so the question is, which way do we want to write the table? It shouldn't matter, but it could make it easier to see the problem. If we write it like this on this side, that's going to be hours per miles. But we know that if they're asking how fast the cyclist is going, we're talking about speed, that's miles per hour, which is how this table's going. So I would recommend, let's go with the table on the right side. Okay, so now we have our table, and we're going to want to figure out, for number 1, says how fast was she going in miles per hour? So you're going to divide your miles by your hours. So you set it up like this, and miles per hour, that means in 1 hour, so that's the unit rate, so divide by the denominator. So for question 1, they were going 12.5 miles per hour, so 12.5 miles per hour for 1 hour. Okay, question 2, at that rate, how long will it take her to go 4.5 miles? Well, if you put 4.5 on the miles side, we want to figure out what's going on the left side. So we're going backwards in the table, which means we're going to divide 4.5 by 12.5 to get our final answer. If you do that, 4.5 divided by 12.5, you will get 0.36 hours. Okay, new situation. Can we use a table? Yeah, definitely. Let's use a table. But the numbers are not going to be pretty. Doesn't matter. You could still use a table. Might even make it simpler when you organize your information. So a recipe for sparkling grape juice calls for 1.5 quarts of sparkling water. Okay. And 3/4 quarts of grape juice. So we're going to set up our table. We got sparkling water and grape juice. Now we could have set our table up the other way with grape juice on the left side and sparkling water on the right. But at the end of the day, you can go forward and backward in a table. So it doesn't really matter. Okay. I could have said the same thing on the first problem, but it just made it easier to explain it that way. But it could have worked if we did the other table presented in problem 1 as well. Anyways, here we go. If you want to find the constant of proportionality for the table, you take the units on the right side, the grape juice, put it in the numerator right there, and divide it by the units on the left side, the sparkling water, put it in the denominator right there. So that's 3/4 divided by 3/2. Remember, 1.5 is the same thing as 3/2. We're going to rewrite that as a division of fractions problem. Of course, we keep change flip, and that will give us 2 times 3 is 6, 4 times 3 is 12, and 6/12. 6 is half of 12, which means that this is 1/2. So our constant of proportionality is a half. All right, so question number 1 asks, how much sparkling water would you need to mix with 9 quarts of grape juice? So on the grape juice side, you put a 9 right there. And we got to go backwards in our table. To go backwards in the table, instead of multiplying by your constant of proportionality, you're going to divide. So we're going to say 9 divided by 1/2. Now we know that the 9 is a whole number. We need to make that look like a fraction. So we got 9/1 divided by 1/2, and same thing, keep change flip. All right, so you would need 18 quarts of sparkling water for 9 quarts of grape juice. Okay, question 2. Now they want to know how much grape juice would you need to mix with 15/4 quarts of sparkling water. So you're going to go to the sparkling water side. You're going to say, okay, well, 15/4, not a pretty number, but I know that 4 goes into 15 3 times, remainder 3/4. So that's 3 3/4 quarts of sparkling water. Let's keep it in fraction form, though, since we're having to do division of fractions. We are going to have to, now we're going forwards to figure out how much grape juice we'd need. So in this case, you're going to multiply by your constant of proportionality. So that's 15/4 times your constant of proportionality, 1/2. 15 times 1 is 15. 4 times 2 is 8. And we cannot simplify this because neither of them are divisible by each other. And, 2 can't go into 15. And, 3 can't go into 8, 5 can't go into 8, so we're just going to leave it 15/8. So there you have it, 15/8. All right, so this last question is a bit of a thinker because they're not asking how much of each specific ingredient you would need. Like, it's not just like question 1 where they're asking about just sparkling water, or question 2 where they're asking about just how much grape juice. They're asking how much of each ingredient would you need to make 100 quarts of sparkling grape juice. So that is a little bit trickier because what we're going to have to do is we're going to have to figure out, well, okay, how many quarts for just one serving of that recipe, right? How many quarts would you need altogether, like of combined ingredients? So what that would be is like that, we're adding it up. But we know that 1.5, that's the same thing as 1 2/4. And that's going to make it easier to add your fractions because the whole number is still going to be 1, but the denominator is going to stay the same, that's 4. And then you add your numerators, 2 plus 3 is 5. 1 5/4, that's improper. So we know that 5/4 is 1 1/4. So 1 plus another 1 1/4, that's 2 1/4, right? So again, 1 plus this right here is 1 1/4. If I write it as a mixed number, if I add those together, 1 1/4 plus 1, that's 2 1/4. Okay, so that is how much of the ingredient, that's how much quarts they are when you combine them. But we want not 2 1/4, we want 100 quarts. So what you're going to do is you're going to say, okay, well, 100, divide that by 2 1/4. Okay, so divide that by 2 1/4. Again, that's a mixed number. You're going to have to use that as improper form. So really that could be 100 divided by, multiply the bottom, add the top. That's going to be 9/4. Put the 1 under it. If you do that, you're going to do keep, change, flip. 100 times 4/9. That's going to give you 400 ninths. Now that seems like, well, what am I supposed to do with that information? What that means is that you're going to take your recipe and you're going to make 44.4 times the amount of the original recipe. That's how many times bigger you're going to need to make it be. In this case, it's easier to do the numbers if you just keep it in fraction form. So here's what we're saying. If you need that many times more of each ingredient to make a recipe that has 100 quarts, what you're going to do is you're going to take 400 ninths and you're going to multiply that times your sparkling water is 1.5. 1.5 is the same thing as 3/2. And if you do that, you're going to get 1200 over 18, which simplifies to 200 thirds, or 66.6 repeating quarts. So a little bit more than 66.5 quarts. Okay. And again, you're going to take the other ingredient. We had 3/4. You're going to multiply that times your 400 ninths, or in other words, multiply that times 44.4 repeating. You're going to get 1236, or if you simplify that, you're going to get 100 thirds. In decimal form, 100 divided by 3 is 33.3. So you're going to need 33.3 quarts of your grape juice in that recipe if you want 100 quarts of the sparkling grape juice. All right, so there you have it. This is how much sparkling water. This is how much grape juice per question number 3. All right, guys, for this question, they give us the information. They tell us how many pounds are bought of ham, and they tell us how many pounds are bought for turkey and how many pounds are bought for roast beef. And they also give you the prices that you pay for each one. They want to know which one is least expensive per pound and which one is most expensive per pound. If you want to know per pound, they literally mean set up a ratio of your cost per pound. And to figure that out, you're going to have to find the unit rate of all 3 meats. And then from there, it'll be really straightforward. So I'm going to set it up for you. So again, that's cost per pound. They tell you the words per pound right there, which means that the pound's going to be the second thing. We're going to make the ham red. But, you know, if you're dividing a decimal number by a fraction, it's best to convert that mixed number into an improper fraction. Now, turn it into a division of fractions problem, like so. And 1450 times 4 is going to equal 58. It's going to be 58. 1 times 7 is 7. And when you divide that, that's equal to 829 per pound. We're going to set up the other ones the same way. All right, so I need to fix one little error. 2.5 is not 5/4, it's 5/2. So now we're basically doing a division of fractions like that. So keep, change, flip. All right, 26.25 times 2 is 52.5. 1 times 5 is 5. Do the division there, and you're going to get the price per pound is $10.50 per pound. All right, now for the last one, we're going to go ahead and we're going to make that one green for roast beef. Roast beef is going to be green. I'm going to just go ahead and do keep, change, flip, change it to multiplication. So I flip 3/8 into 8/3. Now, if you do that, you're going to get 550 times 8 is 44. 1 times 3 is 3. And $44 divided by 3 is going to give you $14. If you round it up, it's going to be 67 cents per pound. So now they ask you, which meat is the least expensive per pound? Well, if you look at it, you know that the red ham is the least expensive per pound, right? And if you look at it again, you're going to see that the green is the most expensive per pound, which is roast beef. So ham is the least expensive, roast beef is the most expensive.